Hi, I'm Mitch. Welcome to my workshop. I'm going to be teaching you woodworking from the very beginning, so I hope you're going to enjoy it. Today I'm going to start out by telling you something about wood, how it's cut from a log and its basic physical properties which need to be taken into account for everything we build from it. This is a slice out of a small eucalyptus tree trunk. Now, trees grow vertically, and you'll know that if you look at the end of a tree trunk you'll see growth rings like these. When you cut boards from a tree, they'll come out of it vertically, like this one here. The tree would have been around this sort of dimension, looking at the growth rings on the end. Now, there are three main ways of cutting boards from a trunk. One is radially, one's plane sawing, and one is flat sawing. Now, flat sawing, cutting straight down boards through the whole width of the trunk, will give you the most board feet out of your trunk, but it also gives you the worst lumber really, because you can have occurrences where knots go from one side of a board to the other. You'll have areas from the centre of the trunk with the pith, which is quite weak, and it's an area where boards will check as they dry out. The next best one is plane sawing, where you tend to avoid the centre of the trunk.
As with flat sawn, you can get cupping and dimensional stability isn't great.
Radial sawing, quarter sawing, produces the most stable boards, but it also wastes the most amount of wood. The most important point I'd like to get across today is how strength is related to the direction the grain runs in. You can see parts of the circles, the annular rings on this board here. So it's being cut horizontally out of the tree. If you think about a tree, what a tree trunk has to do is to support all the weight of the tree trunk above it and all the branches, twigs and leaves. So it's extremely good under compression. So end grain, really good under compression. Now, those grains run down the tree, and you can see them on this slice which is being cut vertically. So you can see the grain running in this direction. What does it have to do? Well, vertically in a tree, it has to resist wind loads.
So it resists breaking if we try to bend it.
Now let me demonstrate those properties for you. This is end grain. Here's a hammer. I've hit it and there's virtually no mark at all there. Takes that pressure without any problem. This piece of long grain, remember the grain going in this direction, if I hit it, you can see the surface is ruptured, there's big dents in it. So it's not as good at taking a load on the long grain as it is on the end grain. Now, the other thing I wanted to demonstrate was how the long grain is really strong, takes all those wind loads in the tree. So using the hammer as a fulcrum here, I shall try and bend that with my weight. And I can put virtually all my weight on there and it won't break. I've even got a much thinner piece here, long grain again. I can put an awful lot of weight on there, it flexes a bit but it's not breaking. Whereas if I go back to the piece that's been cut horizontally out of the tree, see the growth rings on there? It's exactly the same size as this first piece I tried, which I couldn't bend. If I put the long grain on the hammer, apply a bit of pressure, it snaps. Just knowing how the orientation of the grain affects the stress and strain it can take will really help you build things that are much stronger and last longer, or things that are actually practical rather than fail at the first time they're used. Now, for next time, get yourself a little bit of dimensional lumber, 2x2, something like that, and a little bit of scrap, about 1/2 inch thick by about 8 inches long and 4 inches wide, 3 or 4 inches wide. Grab yourself either a fret saw or a coping saw, a pencil, and a piece of board about 1/2 inch thick, 3/4 inch thick, 6 inches wide, 6 inches long, and I'll be showing you and telling you all there is to know about making a jigsaw puzzle out of that for a young child. And in doing that, we'll be talking about the strengths that I discussed today and how designing the jigsaw puzzle will mean whether or not it lasts the test of time. So, see you soon.